this one is a little bit more common, but it's also a little bit more challenging. The reason being is because this time we have B in two different places. Okay? So we're going to look at it essentially the same way. However, what I am going to do first of all is get you to consider this as a power of B. So rather than 1 over B, how else could we write
B to the
-1? Oh my gosh,
It's so
exciting. B to the -1. So in this case, our A is 2B squared. Our B is negative B to the -1. And our N is 12. So that's the first piece of information. So we've identified N, A, and B. We're now going to put that into our general formula as we've been doing up until now. So it's 12R 2B squared to the 12 minus R minus B to the -1 to the power R. Alright, now, this is where it's a little bit different, and we've got B here and also here. So we need to, rather than just look at either 12 minus R or the R to determine the value of R, we need to look at both of them. All I'm going to do is I'm going to ignore the coefficients at the moment. So I'm going to ignore this 2 and this negative. I'm definitely going to ignore this beginning part. I'm going to focus on the B's. So I've got B squared all to the power 12 minus R. If I were to consider that, I would have B to the 24 minus 2R. Because rules of indices tell me that if I've got a power inside and outside, I would multiply those. So this is B to the 24 minus 2R. I'm multiplying that by B to the negative R.
Is it negative B?
It is negative B, but remember, I'm just ignoring the coefficients just for now. Okay, I'm just looking at the powers. So because I've got B to the 24 minus 2R multiplied by B to the minus R, when I would combine that, I would have B to the 24 minus 3R. Because we know that when we're multiplying, we add our powers. Now, this is where we double check to see which term we're interested in. We're interested in when B has a power of 6. So what that means is that 24 minus 3R has to equal 6. We're then going to rearrange that. So 24 take away 6 equals 3R. 18 is 3R. R is 6. So some people had guesstimated R as 6. You would have got the right answer. Doesn't always work out that way, unfortunately. Alright, so now we've established the value of R, we can stick it back in. So we've got 12, 6, 2B squared to the power 6, negative B to the power, to the -1 to the power 6. Because we just established that R was 6, this is a B, and this one was 12 take away 6. I did that bit in my head. Now, realistically, we don't have to worry ourselves anymore about dealing with the B's, because we know that when we expand this out, we're going to have B to the power 6. So all we really need to worry about are the numbers in front. And seeing as they only want the coefficient anyway, we just need to establish the value of 12, 6. So 12 NCR 6, 924. And then we're going to have 2 to the power 6 as well. And as I said, we don't really need to worry about the B's anymore.
Why not?
just because
you don't,
because we know that it's going to give us b to the power 6. Okay, and we just need the coefficient. Do just double check though, this is a negative b, and that's an even power, so we know it would be an even number. But just in case if it had been an odd number, then obviously we would multiply by negative 1 here. And so our final answer is just 9, 24, 64, which is $59,100. Okay. Alright, the only difference between this one is that we've been asked to find the constant term. So sometimes they do ask this, so constant terms means that there are no letters. In other words, we're talking about when the power of x is 0. So everything about the process is exactly the same as we've just done. It's just that instead of identifying that that the power was 6, in the question before you're going to say that the power is 0. So as we did, we're going to first of all write this as a power. So 3 over x to a power is written 3x to the negative 1. Okay, because remember, just our thing on the bottom comes up to the top, and then the value on the top stays there. So n is 9, a is 2x squared, and b is negative 3x to the negative 1. Sticking those into our formula, we've got 9r 2x squared to the 9 minus r negative 3x to the negative 1 r. Concentrating on just the powers of x, so we would have x squared to the 9 minus r and x to the negative 1 for r, so we've got 18 minus 2r plus negative r. Are you happy that I've just gone straight to that? So I'm just looking at these. Can you pause for a second?
But it's minus, so isn't it really minus?
Yeah, so here we've got the left-hand side is the first term. We're multiplying those two terms, so we're adding our powers, which is why we've got plus in the middle. And we know that this expression here has to equal 0 because it's the constant term. So when you see the word constant, you know that your power is 0. So we've got 18 minus 3r equals 0. Funny enough, r is 6 again. Not very original. So this time we're finding 9 6. I did the 9 minus 6 in my head.
Why is that
3.
plus and then circle?
Because I was showing you that we're adding our powers because the terms were being multiplied. Because I did the 9 take away 6 in my head. Again, we only need the big numbers because we're going to end up with our x's disappearing. So we need to find 9 6. Then we've got 2 cubed, so that's 8, and negative 3 to the power 6. 489,000. We had that before, didn't